From the battlefield to the shooting range, bullets have been a cornerstone of modern history. But how are these small yet powerful pieces of technology actually made? In this video, we'll dive into the history of bullets, explore the fascinating manufacturing process, and uncover the innovations shaping the future of ammunition. Stay put to learn how technology is making ammunition more precise and environmentally friendly. But before we dive in, make sure to like this video and subscribe for more behind-the-scenes looks at the technology shaping our world. Bullets have come a long way from their humble beginnings, evolving alongside the firearms that propelled them. In the 13th century, the earliest ammunition consisted of simple rounded lead balls fired from muskets. These crude projectiles were effective for the time but lacked accuracy and range. Yet, they marked the starting point of a technological journey that would forever change warfare. The 19th century brought transformative innovations. One of the most significant breakthroughs was the introduction of the Minié ball in the 1840s. This conical, hollow-based bullet was a game-changer, improving both accuracy and range, making muskets far deadlier. Around the same time, cartridges were developed, combining the projectile, gunpowder, and primer into a single unit. The innovation eliminated the need to handle multiple components during reloading, streamlining the process and increasing the reliability of firearms in battle. By the late 19th century, bullets went through yet another evolution to meet the demands of increasingly powerful firearms. The transition to jacketed bullets was a critical step. These bullets featured a lead core encased in a harder metal shell, allowing them to withstand higher velocities and deliver improved penetration while reducing residue buildup in the barrel. This design quickly became the standard and made way for modern ammunition. Bullets are crafted from a variety of materials, each selected for its specific purpose. Traditionally, lead or lead alloys form the core, often mixed with antimony to increase hardness. These materials have been used for bullet designs for decades, favored for their ability to expand upon impact, causing significant tissue damage. Surrounding the core, jackets made of copper or gilding metal, an alloy of copper and zinc, provide added strength and facilitate smoother passage through the barrel. However, as technology has progressed and environmental concerns have increased, manufacturers have started using alternatives like aluminum, bismuth, bronze, steel, and even plastics. These newer materials offer benefits such as reduced toxicity, enhanced durability, or better performance under different conditions. Shaping a bullet's core is where the magic begins, and there are a couple of ways to go about it: casting and swaging. Casting is the classic method, perfect for softer metals like lead. The metal is heated until it's a bubbling, molten pool, then poured into molds that shape it into the bullet design. Once it cools down and solidifies, the bullet gets a bit of a makeover, trimming off any extra material and polishing it up. Casting is also great for creating bullets with layered materials, like a dense core for deep penetration, wrapped in a softer layer for expansion. This makes them super versatile, whether you're hunting or heading to the range. Then there's swaging, which skips the heat and goes straight to brute force. Instead of melting the metal, swaging uses high-pressure machines to squish it into shape using dies. It's perfect for harder materials or when you need your bullet to be super precise, like hollow points or streamlined designs. No heating means the metal stays just the way it's supposed to be, tough and reliable. For the really hardcore stuff like steel or copper bullets, manufacturers use machining tools like lathes to carve them into the exact shape needed. It's a bit more work, but for these tough-as-nails materials, it's the only way to go. The jacket acts like a protective shell, usually made from copper or a copper alloy like gilding metal, and its purpose is twofold: to enhance the bullet's durability and ensure it performs reliably. The journey starts with raw sheets of copper. In a process known as stamping, these sheets are pressed into molds to form the thin, cylindrical jackets that will wrap around the bullet's core. Alternatively, manufacturers may use electroplating, where copper is carefully deposited onto the core using a chemical bath. This ensures an even layer and avoids adding unnecessary weight to the final product. Sometimes the material for the jacket can be stubborn to work with. That's where annealing comes in. This heat treatment process softens the copper, making it pliable enough to shape without cracking. Once ready, the jacket is carefully fitted around the bullet's core. Usually a lead or lead alloy center, ensuring a snug, secure fit. But it's not just about durability. The jacket also plays a role in performance. It reduces friction as the bullet races through the barrel, preventing lead residue from building up and keeping the firearm accurate and clean. The result comes as a bullet that's tough enough to withstand firing pressure, but precise enough to deliver consistent results. Once the core and jacket are ready, it's time for the fun part, bringing everything together. The assembly process involves carefully combining the various components to create a fully functional bullet. Depending on the bullet design, this step might involve attaching the jacket to the core, securing it with precision to ensure the jacket stays in place when the bullet is fired. For jacketed bullets, the jacket is usually crimped or mechanically bonded to the core, ensuring it doesn't slip off or deform under pressure. In some cases, a soft adhesive or welding technique is used to make sure everything holds tight during the intense forces of firing. The assembly process isn't just about making sure the parts fit. It's about creating a seamless unit that can handle the stresses and strains it will face when it's fired from a gun. Additional components might also be added at this stage, like a primer or powder for certain bullet types, and each part must be checked for consistency and alignment. Once everything is in place, the bullet undergoes final quality checks to ensure it's perfectly symmetrical and ready for action. Before any bullet hits the market, it undergoes rigorous testing to ensure it lives up to expectations. Accuracy, speed, and penetration are the main things that are measured. To simulate real-world conditions, manufacturers often use ballistic gel, which mimics human or animal tissue, to check how well the bullet performs. They also test how the bullet reacts on impact, whether it expands, fragments, or zips through the target. This helps refine the design to make sure it performs the way it's supposed to, whether that means causing maximum damage or just piercing through tough barriers. Once the bullets are all put together, it's time for the final inspection. Quality control is like the last step in a recipe, making sure everything is just right before it's ready for action. Every bullet is carefully examined to ensure it's perfectly symmetrical, with no imperfections like air pockets or size inconsistencies. Random firing tests are also carried out to make sure they perform like they're supposed to, whether it's for a standard firearm or a high-performance one. The goal here is to ensure that each bullet meets the high standards needed for reliability and accuracy. The world of bullets is constantly changing, driven by the need for better performance and growing concerns about safety and the environment. Companies are moving away from traditional materials like lead, which has been used for years, and turning to alternatives like tungsten, steel, bismuth, and even plastic. These changes are happening because of health and environmental concerns, but they come with challenges. New materials don't always work the same way as older ones, so manufacturers are creating new designs to keep up. At the same time, the debate over how lethal bullets should be continues to stir strong opinions. In the US, people have voiced outrage over certain types of ammunition. For example, cop killer bullets, designed to pierce police body armor. And the black talon, which expands into sharp, claw-like tips on impact, have drawn a lot of criticism. These types of bullets have sparked legal battles for years, as people argue over whether such ammunition should even exist. But innovation in the industry doesn't stop, even with the controversy. Designers are exploring ideas that seem almost futuristic. For instance, tank shells with pop-out fins for stability at high speeds could be scaled down for use in personal firearms. There's also talk of pistol-sized launchers that could fire small, self-propelled rockets instead of regular bullets. If these concepts come to life, they might change the way we think about ammunition altogether. From their historical origins to the cutting-edge advancements of today, bullets show the progress in engineering and technology. As the world evolves, so too does ammunition, becoming smarter, safer, and more sustainable for the future. What surprised you most about the process of making bullets? Let us know in the comments. Don't forget to like, share, and subscribe for more videos exploring the fascinating processes behind everyday technology. Fireworks! Whether it's New Year's Eve, the 4th of July, or a massive music festival, there's nothing like watching the night sky explode with vibrant colors and thunderous booms. At their core, fireworks are a perfect mix of chemistry and engineering, wrapped in a dazzling spectacle that's been perfected over centuries. It's big business, too. In 2023, the global fireworks industry raked in over $2.6 billion, and it's only getting bigger. So today, we're going inside the fireworks factory to uncover the secret ingredients, insane precision, and next-level craftsmanship that goes into making these high-flying, jaw-dropping light shows possible. And if you like this topic, don't forget to hit the like button. Before we dive into how fireworks are made today, let's go back, way back. Fireworks originated in China over 2,000 years ago, when alchemists stuffed bamboo tubes with finely ground charcoal and sulfur. Light it up and boom! You'd get a quick flash and smoke, but with no explosion. Initially, they were used in religious ceremonies and festivals to ward off evil spirits. The real game changer came 1,000 years later, when they added saltpeter, a key ingredient in black powder. This discovery changed everything. Suddenly, fireworks could explode, launching fiery streaks into the sky. By the 14th century, fireworks had made their way to Europe, where they weren't just for fun. They were used for warfare, celebrations, and even military victories. In the Renaissance era, Italian pyrotechnicians took fireworks to the next level. They introduced color, intricate designs, and massive displays, laying the foundation for the jaw-dropping fireworks shows we see today. And here's something cool. Some of the biggest fireworks companies in the US are still owned by Italian-American families, a nod to the deep history of Italian pyrotechnic expertise. Fireworks might seem like magic, but they're really a perfect mix of chemistry, physics, and engineering, all coming together in an explosive display of color and sound. At their core, every modern firework is made up of 3 essential parts. The shell, the outer casing that holds everything together, protecting the delicate components inside until it's time to ignite. The stars. These are the tiny pellets packed with metallic compounds that determine the colors you see in the sky. Different combinations of metals and minerals create different colors and effects. The black powder and fuse. The black powder is the explosive charge that propels the fireworks sky high, while the fuse controls the timing of the detonation. The moment a firework is ignited, a chain reaction begins. First, the launch charge fires, blasting the firework up into the sky like a rocket. A time delay fuse burns as the firework soars, ensuring it reaches the right height before anything explodes. Once at peak altitude, the burst charge ignites, setting off the stars inside the firework, creating those dazzling patterns and explosions of color. And speaking of color, here's a cool chemistry fact. Each color in a firework comes from specific metal compounds reacting to extreme heat. Blue, copper compounds burning at high temperatures. Red is thanks to strontium carbonate. Green, that's the barium nitrate in action. White and silver, the effect of burning magnesium or aluminum. Gold and orange, those come from iron and charcoal, creating that fiery glow. It's pure science, designed for maximum spectacle. And now that we know what makes fireworks explode, it's time to head inside the factory and see exactly how they're made. Before a single spark flies, fireworks start on the drawing board. Pyrotechnic engineers don't just throw chemicals together and hope for the best. Every explosion is carefully planned and calculated for maximum impact. Color, size, and explosion effects are all mapped out down to the millisecond. Will the firework burst into a giant golden willow? Will it crackle like lightning? Or maybe explode in perfect rings? Every tiny detail has to be precisely engineered. High-tech simulations allow designers to visualize the final result. Advanced software helps predict how the fireworks will move through the air, ensuring perfect symmetry and timing once they launch. But it's not just about looks. Each firework needs to perform consistently and safely. So, before anything goes into full production, manufacturers test different chemical formulas and detonation sequences, fine-tuning every reaction to get the perfect explosion. Once the design is locked in, it's time to bring the blueprint to life. Every dazzling burst of color in the night sky comes from tiny pellets called stars. These are the fuel for the light show, packed with chemical compounds that ignite mid-air to produce brilliant colors and effects. Raw ingredients like oxidizers, fuels, and metal salts are carefully measured and mixed in massive batches. The exact combination determines how bright, colorful, and long-lasting each firework effect will be. Next, the mixture is sifted and refined. Any clumps or inconsistencies could ruin the explosion, so factories sift the powder multiple times to ensure a fine, even texture. Then, water is added to create a dough-like paste. This makes the mixture moldable and ready to be shaped. Some factories press this paste into thin sheets, while others cut it into small cubes. These cubes are the actual stars that will ignite inside the firework. Now, it's time to dry. These stars are left to harden for several days, sometimes even weeks, to make sure they're completely dry before use. If moisture remains, the fireworks won't ignite properly, or worse, they can misfire. Some fireworks contain hundreds of stars, each one meticulously placed in a specific pattern, so that when they explode, they form precise shapes in the sky. Now that we have the stars, it's time to build the firework itself. This is where all the precision, artistry, and explosive power come together to create those stunning sky-high displays. First, the shell is crafted. Firework casings are made from thick paper or plastic, strong enough to contain the explosion, but light enough to launch high into the sky. Inside, the shell is divided into multiple compartments, each carefully designed to hold different charges for multi-stage bursts. The secret to a perfect explosion? Placement. Every star, fuse, and black powder charge is meticulously arranged inside the shell. Even the slightest misalignment could throw off the entire firework, so this step is often done by hand, ensuring pinpoint accuracy. A firework isn't just about explosions, it's about precision timing. Every firework needs a carefully designed fuse system to ensure it launches, ignites, and bursts at exactly the right moment. The time delay fuse is the master fuse, controlling when the firework will detonate. Without it, fireworks would explode too early, too late, or not at all. These fuses burn at a controlled rate, allowing the firework to reach its peak height before igniting the burst charge. Thin fuses filled with gunpowder or flash powder snake through the inner compartments of the firework. Their job? Trigger each stage of the explosion in perfect sequence, whether it's a multi-stage burst, color-changing effect, or crackling finale. These internal fuses make it all happen. Want extra impact? Enter flash powder. Some fireworks get an added dose of flash powder, a high-energy explosive mix that produces massive bursts of light and a thunderous boom. This is what creates the deep, echoing sound waves that make fireworks feel as powerful as they look. Now that the fireworks are fully packed with stars, fuses, and explosive charges, they aren't ready to launch just yet. They need one crucial finishing step: drying. Fireworks are packed with gunpowder and delicate chemical mixtures, all of which are highly sensitive to moisture. If the compounds absorb even a little bit of humidity, the firework might fail to ignite, fizzle out mid-air, or explode unpredictably. The solution? Temperature-controlled drying rooms. To prevent any disasters, fireworks are placed in specialized drying rooms where temperature, humidity, and airflow are strictly controlled. Too slow? The chemicals won't bond properly. Too fast? And the shells might warp or crack. Once dried, each firework undergoes a final quality check. Workers inspect for cracks in the casing that could affect the explosion, loose components that might shift and ruin the fireworks pattern, defective fuses that could cause a misfire. Only flawless, perfectly assembled fireworks move on to the next step: packaging and transportation. The rejects? They're carefully dismantled, with the usable materials recycled into new fireworks. Fireworks aren't just tossed into a box. They're carefully packed with shock-absorbing materials to prevent accidental ignition from friction or impact, damage to the shells that could ruin their performance, and movement inside the box, keeping everything stable during transport. Since fireworks are classified as hazardous materials, each package must be labeled with explosive hazard warnings for proper handling. country-specific safety guidelines, since fireworks laws vary across the world, and batch tracking codes, so manufacturers can trace shipments in case of recalls or issues. Once packed, fireworks are carefully transported using strict safety protocols, whether they travel by ground, air freight, or by sea shipping. The final destination? Festivals, holidays, and major celebrations across the globe, ready to light up the sky and thrill millions. From small backyard fireworks to massive stadium-sized displays, each one started as a simple shell in a factory, waiting for its moment to shine. A great fireworks show is a carefully choreographed performance, blending timing, color, music, and technology to create an unforgettable spectacle. Modern fireworks shows rely on computerized firing systems that allow pyrotechnicians to time each explosion down to the millisecond. Every burst of light and color is meticulously programmed to sync perfectly with a musical score, creating a seamless experience that tells a story in the sky. Some of the biggest displays even use GPS-guided drones and digital mapping to enhance effects, combining traditional pyrotechnics with cutting-edge technology. Planning a show of this magnitude takes months of preparation. Pyrotechnic teams select the right mix of fireworks, design the explosion patterns, and conduct multiple dry-run simulations to ensure everything fires in perfect sequence. The final launch is controlled by a central command system, which triggers thousands of fireworks across multiple launch sites, all synchronized in perfect harmony. So, the next time you see a firework light up the sky, remember, it's not just a random explosion. It's the result of thousands of years of chemistry, engineering, and pyrotechnic artistry. So, tell us, what's your favorite firework display? Let us know in the comments, and don't forget to like and subscribe for more behind-the-scenes deep dives.